Okay, we're going to review radicals and geometry. Simplify the square root of 180. Now, is 180 a perfect square? No, it is not. So it's an irrational square root. So we need to divide it into two square roots where one's a perfect square. So 180 divided by 169. Nope. 180 divided by 144. Nope. 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 Cha-ching. Okay, so I write that as the square root of 36 times the square root of 5. And then the square root of 36 is 6. So 180 is equal to 6 times the square root of 5. Okay, 16. Well, this is not irrational. It's a perfect square root. It's 4. 15. 15 is irrational. But you start dividing 15 by 9. Nope. 15 by 4. Nope. So that takes you to 1. So when you're taking to 1 with that, you just circle that. Because 15 divided by 1 is just 15. So that's not really going to change anything. Okay, now we're going to be simplifying some more complicated expressions. We have the square root of 45 times x to the third times y to the 6th times z to the 11th. So I have 4 factors in that square root that as of now cannot be multiplied together. So what I need to do is break up the square root so it covers each factor individually. Okay, so there's 4 of them this time. So 45, that's irrational. The 45 you do just like you did on the first page. Okay. So I would divide 45 by 36 decimal, by 25 decimal, by 16 decimal, by 9. 9 I got 5. Okay. So 9 and 5. So the square root of 9 equals 3. So that equals 3 times the square root of 5. Now, so you're going to have a factor of 3 outside and a factor of 5 inside. Now, the variables. Now, you don't know what value those are, but you can break them up. You know it's 3 factors of whatever that is. So you put square root over 2 of them at a time. But if there's one at the end, you just put it in square root. That'll be remaining. So x times x is x second, but what's a square root and a second power do? They cancel, and they give me just a full factor of x. So we have a full factor of x and a square root of x. So we put x out and x in. Now y to the 6, y times y times y times y times y times y. So 2 at a time. So y times y to the second, but the square root and the second cancel, giving me the full y factor. Y to the second, but the square root cancels, full y factor. Y to the second, y factor. So there's 3 full y factors and there's no square root left over. So that y to the third goes out. Okay. Now z to the 11th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. And I think by now you should know what happens here. Okay. I mean, that's going to be a z, 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 z. This z here will remain in the square root. So that's 1, 2, 3, 4, 5 full factors of z, z to the 5th. Then a z left over in the square root. So z to the 5th out and z in. Okay. Alright, now what are you doing with these? Well, it's all multiplication. If it's all multiplication, you think of that in terms of 3 steps. Okay. The first step, you multiply the outer coefficients, and on that same step you multiply your square roots. Okay, so that's taking 5 times 2, which is 10, and then the square root of 5 times the square root of 15, which is the square root of 75. Okay, not hard there. Second step, you have to simplify your new square root, which would be the 75. The 10 just drops. So 75 is an irrational square root. If you don't see it, it's not a perfect square, so you put in the division sign. So 75, is it divisible by 64? Nope. By 49? Nope. By 36? Nope. 25, okay? So, square root of 25, square root of 3. So the square root of 25 turns into 5. So instead of 10 times the square root of 75, it's now 10 times 5 square root 3. Okay? And then the third step's easy. You just multiply your outside, which is 50, times the square root of 3. You don't multiply anymore. You can't multiply a coefficient by a square root. Okay, now, different game here. That's times, this is plus. Plus is totally different set of steps. You got to get like terms. That means, see the 5 and the 4, they're multiplied by 2 different square roots. We want to get the coefficients so they're multiplied by the same square root in order to add. So I make a table, and on one side I will simplify 5 times the square root of 60, and on the other side we'll simplify 4 times the square root of 15. So I drop the 5 down, put the division sign in, just put the square roots there. So 60 divided by 49, nope. 36, nope. 5, nope. 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 Okay, 4 and 15. So the square root of 4 times the square root of 15. See, the square root of 4 times the square root of 15 is the square root of 60. This is like taking it backwards. The square root of 4 turns into 2. So 5 times 2, square root of 15. Okay, and then that's going to be 10 square root 15. Now I think that one's already simplified, okay, because you got 4 times, but we'll go through the process. 15's irrational. It's not a perfect square root. So 15 divided by 9, nope. By 4, nope. So it comes to 1, so we don't want to do 1. We're just going to keep it as a square root of 15, okay. I mean, you can do 1, but it's a waste of time because it just ends up as the same. So 4 times the square root of 15. That stays the same. Now, they are like terms because the 10 and the 4 can now be added because they're both multiplied by the square root of 15. So I put square root of 15. It's similar to 10x plus 4x. Same concept. That's 14x, so it would just be 14 square root of 15. Okay, so that's your radicals, and now you got a bunch of right triangles that we have to deal with. So we have to solve for x and y in this triangle. The sides, find out how long the sides are. Okay, you know this side is 15. Now, if I don't know 2 of the sides, you know you're going to have to use proportions. But you don't need to write the sine, cos, the SOHCAHTOA because this is a special, 30, 60, 90 is a special right triangle. So on special right triangles, you want to write your degrees in lowest to highest, 30, 60, 90. Now remember how those work. Across from the 30 is 1, okay? Across from the 60 is a square root of 3, okay? And then across from the 90 is a 2. So, put those in parentheses beneath the actual values. These are the ratio values, these are the actual. So across from the 30 you got 1, across from the 60 you got the square root of 3, across from the 90 you got 2. Now we're set to go. See, x would be x over the square root of 3, and then in the y it'd be y over the 1. Now in both these we use where we know the actual side, put the 15 over the 2, and then the 15 over the 2 here. So now we solve for x, but remember, you know you can't multiply those, so just write 15 times the square root of 3 divided by 2. Now you can divide the 15 by the 2, it's a decimal, so you can put 7.5 times the square root of 3, or if it's a decimal you can just leave it as a fraction, which would be 15 square root 3 over 2. I'm good with either form of the answer. You don't have to reuse both of them. Okay, y equals, this is pretty easy, it's just 1 times 15 divided by 2. Now we don't have square roots, so we can multiply these. 15 divided by 2. And 15 divided by 2 is 7.5, or you can keep it as 15 over 2. I don't care. Okay, next one. Again, you got to find x and y. So there's two unknown sides. Anytime there's two unknown sides in your job in the problems, to find them, you're going to need proportions. Okay? But again, we don't need the sine, cosine, tangent, because that's 45, 45, 90 is also a special right triangle. So 45, 45, 90. Well, these are the same 2 degrees, so they have to have the same 2 ratios, and they do. 1, 1. And then the 90 is the square root of 2. It's the square root of 2, not 2. So, across from 45, that's 1. Across from the other 45, that's 1. Then across from your 90 degrees is the square root of 2. Okay, so x over 1, and y over 1. Okay, then we put 9 over the square root of 2 on both of these. We have to solve for x. Okay. So we will take 1 times 9, that's well and good, but divided by the square root of 2. Okay. So 1 times 9 is fine, that's 9, but you can't divide the 9 by the square root. So you can divide, you need to take times, and put square root of 2. 9 times the square root of 2 is, you can't have that square root on the bottom. Okay, and if it's on the bottom, you have to rationalize it by multiplying by the square root that you want out of the bottom. Okay. Now the square root of 2 times the square root of 2, it's not 4. Okay, it'd be the square root of 4, but that's 2. Just look at that. Square root of 2 times square root of 2 is 2. The square root of 5 times the square root of 5 would be 5. The square root of 10 times the square root of 10 would be 10. And this was just, you can't multiply those, but it's 9 square root of 2. Now, what's important is now I can divide 9 by 2. That'd be 4.5 square root 2. Or, you could leave it as 9 square root 2 over 2. If it's a decimal. If it's a whole number, I want it divided no matter what. Okay, and then this is going to be the exact same thing. We're solving for y. So, 1 times 9 divided by the square root of 2. 1 times 9 is fine, that's 9. But you can't divide a coefficient by a square root, similar to how you can't multiply it, but. So, times square root of 2 times square root of 2. So that'd be 9 square root 2, but on bottom that's 2. Again, let me reiterate why that's 2. The square root of 2 times the square root of 2, that'd be the square root of 4, okay? But the square root of 4 is equal to 2. That's how that works. Now, then it's going to be the same thing. You can divide and put 4.5 square root of 2, or you can leave it as 9 square root 2 over 2. X and y have the same thing. Okay, next problem. Find the 3 trig ratios of the angle theta. Okay, so sine of theta, cosine theta, tangent of theta. Well, obviously sine, cosine, tangent, you're going to need your SOHCAHTOA. So sine, cosine, tangent. So sine is O over H. Write those down. The cosine's the A over the H. The tangent's the O over the A. So what do we know? What don't we know? This is one's all about the sides. Okay. So your H is 25. Nice. Okay. Now that's the H. The hypotenuse is always opposite the right, the 90-degree angle. Now to do your O and A, the opposite and the adjacent, you have to mark your reference angle. The reference is just the theta symbol. There are no degrees. So you go across from there. That's your O, the opposite. And we know that's 16. A is the one we don't know. So O over H. So that's 16 over 25. So the sine is good. The cosine, that's A over H. A we don't know. H we know is 25. Tangent's the O over the A. So it'd be 16. We know that, but we don't know the A. Now, there's only one side to find, not two. So if there's not two, we don't use proportions. One side to find, you use the Pythagorean Theorem. See, on those problems we just did with the x and the y, those were two sides we had to find. Now there's one side to find to complete this problem, Pythagorean Theorem. And that's a squared plus o squared equals h squared. Okay? So a we don't know. O we know is 16 to the second, and H we know is 25 to the second. Okay, so 16, A to the second, A we keep in variable form. 16 times itself is 256. 25 to the second, 25 times itself is equal to 625. Now you solve for the A using the linear properties, so you make a wall on that side. You obviously got to move the 256. And 625 minus 256 is going to be 369. Now I need to find the square root of 369 to solve for A. Okay, 369 is irrational. It is not a perfect square. So we go 369 divided by 324 decimal, 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 decimal. It's not going to divide by 100. It has to end in two zeros for that to even be possible. Decimal, 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 decimal. Okay, 9 and 41. So the square root of 9 times the square root of 41. And of course the square root of 9 is replaced with 3. So A is 3 times the square root of 41. So 3 square root 41. There's your cosine. 3 square root 41. On sine, cosine, tangent, I don't care if that's in the denominator. Okay, you don't divide those, you keep them as ratios. Okay, then the next problem. Find the three sides and three angle measurements. So sides and angles. You got the sides are the hardest. The angles are easy. Okay, so it is a random right triangle, not a special one, because it's not 30, 60, 90, and it's not 45, 45, 90. Okay, so random right triangle, you're going to need the SOHCAHTOA to solve it. So, sine, cosine, tangent. So what do we know about the sides? Well, we know we don't know the H. Now for O and A, you need your reference, okay? Now you don't use theta, there's an actual degrees in there. So you want to use 33 degrees as your reference. Don't put theta yourself ever, okay? So your O, well, we don't know the O, and the A I know is 8. Okay, so there's two sides to find, not one side. So Pythagorean Theorem's out, and you use your proportions. In your proportions, you have to put the 33 degrees in parentheses on that first proportion. Okay, now your sides. Now remember, before 33, then you put the sine, cosine, tangent. But that depends on what we're finding. We're going to find the O here and the H here. Now A is the side I've got. Okay, so I need A in both these proportions. So O and A is tangent. So it'd be tan 33 degrees over 1. And then O over A. We'll get the A over out of there, and that's 8. And then I'm solving for O. So tan 33 times 8 divided by 1. Okay, I got 5.20. There's your O. Then the H and the A, that would be the cosine. And that's A over H. You don't go with what you wrote here. You go with up there. It's always A over H. Okay, so A we know is 8, and then I'm finding what the H is. So 1 times 8 divided by cos 33. Okay, 9.54. Okay, angles. So you know you got 33 degrees. That's your reference. You're always going to have 90. And the remaining, you just take your 180 minus your 90 minus your 33. 57. Okay. Okay, there you go. Okay, and the last problem. Find the area of the regular decagon. Sorry about that crap that I put, that the printer put inside. So area equals. Okay, so here's your area. S times N times A divided by 2. Well, S and N are easy. S is the side length. Every side's 5. Okay. How many sides? Well, 12. It's not a decagon, I guess. Okay. Now, A, your apothem. Okay. Just go through all this crap. That's about the middle, and draw a line that goes straight and splits that in half. Okay. Okay, it's a right angle, and this is the apothem. Okay. You're finding how long that is. Well, you're going to make a right triangle, that same thing. Okay. And there's two things you know. You know how long that side is. Now, what's half of 5? Well, divide it by 2, and you get 2.5. To find half of a number, you just divide it by 2. So 2.5. Now, you also need to find the degrees. Okay? Now, remember how the degrees are found. You take 360 divided by n, the number of sides, which is 12, and then divided by 2. Because again, don't write that down, but just dividing it by 12, or write that down. Yeah, write that down, but this little dash thing, just dividing it by 12 finds the degrees in that whole thing. See, I just want half of it, so that's why I divided by 2. So 360 divided by 12 divided by 2 is 15 degrees, so not a big degree measurement. Now, you only know one side, okay? You don't need to find 2, but you need to use proportions to find it, okay? Alright, so H I don't really care about, but I'll label it. Now, the reference is the 15 degrees. So O, I have the value for O, and then A is that apothem I need to find, okay? So you put your reference degrees here. And we need to find the A, the apothem, there's A, and you want to put that with the O because you actually have a measurement for side O. So A and O is tangent, just like always. And that's O over A, TOA, tangent. So A is what you're solving for, O is 2.5. Okay. A equals, so to find the A, we take 1 times 2.5 divided by the tangent of 15 degrees. .33. That's your A, that's your apothem. You now know the apothem length, 9.33. So you take that up here, and now you're ready to find the area. 5 times 12 times 9.33 divided by 2, 279.9. Okay. Remember, areas is square units, so it'd be square feet.